Welcome to qnawire.
In this question, we are given as inside an elevator, I have a spring and block arrangement as shown in the figure. The spring constant of the spring is again 100 Newton per meter according to the previous question. The block is having mass 2 kg. The elevator is moving upward with an acceleration of 2 meter per second square. So we have to find the elongation of the spring. Okay. So if we leave the block under gravity, so due to gravitational force on the block 2 kg, the block will be displacing downward by an amount of x. Okay, so now the net force that is acting on the block downward is 2g due to the gravity, and one more force will be acting downward which is due to the pseudo force, and that will be 2 times a. And on the block the upper force is the spring force, that is k times x. So now with respect to WRT represent with respect to elevator's frame of reference, the block is in equilibrium. The block is in equilibrium, so the net force on the block has to be 0, and following that condition you can write the net upward force, which is kx, has to be balancing 2g plus 2a. so from here we can write x is going to be 2g plus 2a by k. We can put the values of g and a, so we will get 2 plus 2 into 9.8 plus 2 into 2 by k is 100. On simplifying this we will get x equals 0.236 meter. So on rounding it off up to a correct significant figure we will get this around 0.24 meter. So this is the answer for the first part of this question. Right, on the second part of this question we are adding one more 1 kg mass with the block, so the total mass of the block will become 3 kg, and in this case because of the addition of 1 kg mass the spring will be further elongated. Let's say the elongation of the spring is x1. So in this case on 3 kg mass, net force that will be acting downward will be due to pseudo force, that will be 3 into a. In addition to that, due to its weight, one more force will be there, that is 3 into g. On the spring there will be a net force of kx plus kx1, because the net elongation of the spring will become now x plus x1. So again with respect to elevator's frame of reference, if we find the equilibrium condition for 3 kg mass, so for equilibrium of 3 kg with respect to elevator's frame, we can write that net upward force, that is kx plus kx1, has to be balancing 3a plus 3g. So on simplifying this we can write x1 equals 3a plus 3g minus kx by k. We can put the values of these parameters. So 3a is 2 plus 3g we have taken 9.8 minus k is given to us 100 into x we got 0.24 divided by k we got 100. So on simplifying this we will get x1 equals 0.12 meter. So this is the answer for the second part. So the further elongation of the spring is 0.12 meter.